Okay, this is differentiation packet 42B, number 9. It's again a related rates question, and we're looking at sand creating a sand pile, and that sand pile is shaped like a cone, and we know the height and base diameter are always equal. So first off, we want to start with a diagram. So here's my sand pile. We know that the height, which we'll call h, and the diameter are the same, which means the radius is going to be half h, right? Because the diameter is the same as height, so the radius would be half of that, so half h. Let's see, what do we know? We know that sand is coming in and creating this pile at a rate of 2 cubic feet per minute. So if we're a little bit unsure as to what that exactly represents, we can look at units, and cubic feet tells me volume, right? Cubic units are volume, and it's per minute, so it's going to be a rate. I'm thinking dV dt equals 2. At what rate is the height growing? So that tells me what I want to know. I want d height dt. Right, so that's my big question, and it tells me when the pile is 5 feet high. So height, 5 feet. Okay, so I have done my diagram. I've listed all of my facts, so that's everything that I know or that I want to find. And the next thing I need to do is come up with an equation. So this is a cone, and we're using volume, so it seems like a volume equation would be good. So if we remember, volume of a cone is 1/3 pi r squared h. However, when I look at this volume equation, I see v, and then I see two variables on the other side, and those two variables are being multiplied, which, if I'm going to have to differentiate, tells me I'm going to need a product rule, I'm going to have a dr dt. That sounds a little bit annoying. However, I do know that r is equivalent to 1/2 h. So before I differentiate, I'm going to replace my r with a 1/2 h so that my volume equation doesn't have 3 variables, it'll only have 2, and I don't need a product rule. So 1/3 pi 1/2 h squared h. So I think that comes out to be 1/12 pi h cubed. There, so now I have a nice formula. It's got a v and an h. Both of these variables I care about. They're both changing. I either know or want the rate. So we differentiate. The derivative of volume is dv dt. 1/12 pi is just a coefficient, so it stays there. The derivative of h cubed is 3h squared dh dt. And now that's what I want, right? dh dt. And do I know everything else? I do know what h is, so that's going to be good here. And I do know what dv dt is, so that's going to be good here. So now I can plug in and solve. So I've got 2 equals, let's see, 1/12 pi times 3 is 1/4 pi. So that's an equals. I know my h is 5, and then dh dt is what I want. So on the right side, I'm gonna get 25 over 4 pi times dh dt equals 2. So I'm gonna just divide over the 25/4 pi to get dh dt alone. Let me see if I can squeeze that in here. I'm gonna have 8 over 25 pi equals dh dt, and if we want a decimal, that is 0.102 equals dh dt. This is bad notation. 0.102, that's the rate of my height changing. dh dt, so my units would be feet per minute. R